The previous video was about natural log and where it came from in e to the x. Today we're going to be looking at the integration of e to the x. And it is one of the easiest antiderivatives you will ever take, just like it is one of the easiest derivatives you will ever deal with. It is so easy that I am going to go as far as to guarantee you that e to the x is going to require you to use some sort of other method, either u sub or chain rule, to deal with it, because it is so straightforward and so easy that it's literally itself. If you recall, the derivative of e to the x with respect to u was e to the u du dx. So when we integrate e to the x, it should not be a surprise, e to the u, it should not be a surprise that we will simply get e to the u plus some c. That makes this an incredibly simple topic to have to go over. If I look at a problem, my first question should be, when I look at e to the 3x plus 1, is can I take the antiderivative of e to 3x plus 1? And no, there's a chain rule. The chain being the 3x plus 1 portion, making this du is 3dx. So when I rewrite this problem, I get 1/3 the integral of e to the u du, or 1/3 e to the u plus c, which is really 1/3 e to the 3x plus 1 plus c. And essentially every problem we're going to deal with at this point in time is going to be the exact same setup. If I were to look at 5x, e to the negative x squared, I look and I realize, hey, negative x squared is a chain rule. There's no manipulation, nothing I can do there. So I say u is going to be the negative x squared. That would be my chain. Now I do see a product rule, so maybe this will cancel that out. I say du is negative 2x dx. And I'll notice that I've got an x dx and an x dx, so that x would fall out. I'm going to pull the 5 out. I've got a factor of negative 2, so I'm going to have negative 1/2 here. E to the u du, or negative 5/2 e to the u plus c, which is negative 5/2 e to the negative x squared plus c. And every single problem is going to be basically the same exact setup. I would suggest pausing the video on this next piece and seeing if you could try out this next example, e to the 1 over x squared dx. I'll give you a moment to pause it. Hopefully you've taken the time to do that. I would have selected u as 1 over x, or x to the negative 1. Then if I take the derivative of that, I would get negative x to the negative 2 dx, or rewriting that, negative 1 over x squared dx, and you'll see that these x squareds would cancel. Meaning I could rewrite this problem, the negative integral of e to the u du, negative e to the u plus c, which is negative e to the 1 over x plus c. As I said before, every single one of these is going to basically work out the same exact way. Again, I'll give you a moment to pause the video to try the next question. After you've done this problem and you get a look at it, you should see that your u would be 2x plus 1. That's where my chain is. My du would be 2dx. So rewriting this integral, I should get 1/2 e to the u, du, not plus c yet, where u, when the x is 1, u, which will be 2 times 1 plus 1, will be 3, and u, when x is equal to 4, will be 2 times 4 plus 1, which is 9, giving me the integral from 3 to 9. This leaves me with 1/2 e to the u evaluated from 3 to 9, or 1/2 e to the 9 minus e to the 3. There could be some factoring we could do here. I'm going to leave the answer as it sits. I could factor out e to the 3rd if I felt the desire to do so. Don't have to, though. All pretty good stuff. As we wait for the Promethean board that's not responding to move forward. There we go. We look at the next problem. E to the x over e to the x plus 5. I'll give you a moment to pause the video and see if you could solve this problem. Hopefully, as you look to this question, you recognize that there was no actual manipulation. Had this have been flipped, had this have been e to the x plus 5 over e to the x, that would have been one we could have manipulated. We could have called that e to the x over e to the x plus 5 over e to the x. Or we wrote that 1 plus 5e to the negative x. And so we could have manipulated it had it been flipped, but since it's written the way that it is, this turns into a u sub question of e to the x plus 5, where du is e to the x dx. And you can see this is e to the x times dx, e to the x times dx. Those would cancel here and here, leaving me with the integral of 1 over u du. Now we're into something interesting. This is now a natural log question. Now we have the natural log of the absolute value of u plus c, or natural log of the absolute value of e to the x plus 5 plus c. So please be aware that not every question is going to end as an e to the x question. Not every question is going to end as a natural log. You have to be able to manipulate some of these questions. Beyond that, the other two questions are all going to be fairly straightforward. There's not much else to do with e to the x, folks. It is a beautifully simple antiderivative to take. So I'm hoping that at this point that's not too bad there. Let's go ahead and go through this last one real quick. If you want to go ahead and pause the video and try out this last one, I'll give you a moment to pause and do that. Hopefully what you recognized is just like the previous question, u would be 1 plus e to the x, making du e to the x dx. So this problem eventually turns into another natural log antiderivative, where when x is equal to 0, u would equal 1 plus e to the 0, which would be 2. And when x is equal to 1, u being 1 plus e to the 1 is 1 plus e, and this is weird. That is a gross looking upper limit, but it's okay. We're just going to substitute it in at the end. It should make life pretty easy. So this becomes the natural log of the absolute value of u from 2 to 1 plus e, which is the natural log of 1 plus e minus the natural log of 2. And I'm going to leave the answer there. You know, there are some groups that will tell you should really write that 1 plus e over 2 using that rule 3 and 4 from yesterday. You don't have to write that. Either of those would be perfectly acceptable solutions. And on the AP test, from what I have seen, the multiple choice questions would actually be written like this first solution. Although if we look at older questions from the AP test, they may give you this second. So just be aware that those two options are out there. They're available. I hope that this all made reasonable sense. I look forward to seeing you all tomorrow. Just as a heads up, tomorrow, what day is it today? Today is Tuesday the 20th, February 20th. Tomorrow, February 21st, we will be doing our TELPAS writing sample and then working natural log and E questions. So I look forward to seeing you all tomorrow and taking care of business. Have a fantastic day.